Yeah, we will discuss today's square root topic. Okay. And today we will see Vilokanam. In this Vilokanam Sutra, we are using unit place digit concept. That means based upon unit place digit, we are going to solve the problem. Okay. Now, if you see, let me take here squares list. Okay. Yeah. So here, this is the square root symbol. Under the square root symbol, we are writing some number. Okay. And this symbol is called, what this symbol is called? Radical. Okay. Radical. And this x is called radicand. Clear my point?
Yes.
This is the nth root symbol actually. Okay. Right. So the square root symbol we are writing simply here with two value, or else we can write this symbol simply like this also. Why? Because both are same. You can write with two or without two. The square root symbol will be same. Okay. So what do you mean? What is the meaning of square root here? Okay. Suppose we have uh, 2 square we have. Okay. Then we are getting 4. So it is a reverse procedure. Okay. Square root is a reverse procedure to identify the number which is squared, so that we are getting 4. So if you put the 4 under root, then it says that the answer is 2. This 2 is squared, so that is the reason. That is the reason I am getting 4. So it is a reverse procedure of this square. Okay, clear my point.
Okay, sir.
Not clear.
Okay, sir.
Sorry.
Right, sir. Okay.
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 Yeah. So we are talking about here today Vilokanam. Okay. Vilokanam Sutra, how we can use to find the square root of a number. So Vilokanam Sutra we can use for every number or any special numbers like a perfect square or non-perfect square. So the Vilokanam Sutra today we are using for finding the square roots of, okay, square roots of perfect square numbers. So we know that what is a perfect square here. The perfect square is nothing but, suppose 2 square is 4, 9 square is 16. Okay. and 11 square is 120. So the numbers like 4, 16, 121, all these numbers we can call perfect square numbers. Okay, perfect square numbers. So the in between number, if you see here, like 5, 6, 7, 8. Okay, 9 is a 3 square, so we cannot take 9 here. Are you getting my point? Then 10, okay, 11, 12, 13, 14. Why I'm not taking 9 here? Why? Because 3 square is a perfect square. So all these number we call example non-perfect square. Okay, non-perfect square. Do you understand what is the perfect square number and non-perfect square number? Yes. Is it clear or not?
Okay, sir.
Clear. It's clear.
Yeah, okay. Yeah. Now we can use unit digit concept by the Vilokanam. If you see here, I have squares. Okay. If you observe all these square numbers, suppose the number 1 square is ending with 1. Am I right? And you can see here the 11 square also ending with 1. And here 9 square also ending with 1. And you can see here 19 square also ending with 1.
21 nurse.
Okay?
21.
Yeah, 21 also ending with 1. That 19 also ending with 1.
29.
So, yeah, 20. So, what we can observe from these numbers,
1 or 9.
yeah. So, if any number, if you are squaring, that number either it is ending with a 1 or that number is ending with 9. Then, if you are finding the square of those numbers, all those numbers is always ending with 1 only. That means this is the perfect square number. Are you getting my point? Or because we have squared that number. So by seeing the unit place digit, what we can decide here, maybe the answer is or maybe 9. Maybe 9. Whenever the perfect square number is ending with 1, then we can say that that answer either ending with 1 or ending with 9. Are you getting my point?
Yes.
Okay,
You,
sir.
sir?
Okay, sir.
Okay.
This is called observation. And if you see here, 2 square is ending with 4. And 8 square also ending with 4. And 14 square also, oh no, 14 square is ending with, no. So 12 square is ending with 4. And,
18.
yeah, 18 square also ending with 4.
22.
The 22 also ending with 4.
28.
And 28 also ending with 4. So
Wait.
if you see, observe all the things here, what we observe, whenever any number is ending with 2, that means unit place is 2. and you are finding the square of the number, or if any number is ending with 8, and if you are finding the square of that number, then answer is ending with
4.
4 only. Yes.
Okay, sir.
So based upon this number, we can decide that unit place digit of the resultant. So this is a perfect square number. If you are finding the square root of that perfect square number by the observation, unit place digit is a 4, so that we can say that answer of the unit place either 1 or 2 or 8. Either it is a unit place digit of the answer is either 2 or 8. In this way, we can decide. Are you getting my point?
Yes, sir.
Why? Because if you see here, it is the ending with 1, it is ending with 9. Am I right?
Okay.
Then if you find the square of that number, then square is the ending with 1. If you see some squares I take in here, you can see it is ending with 1, and here ending with 1, here ending with 1, here ending with where is the ending with 1? Yeah, here ending with 1, ending with 1, here also ending with 1. So whenever the number is ending with 1, unit place also 1, you can see. And then 9. You can see 1 here. And in this case 9. So in this case, what happened? Whenever we are deciding the unit place digit of the answer, in the case of finding the square root of perfect square numbers, we have two possibilities. Are you getting my point?
Yes.
So let me write now those possibility list. Right. So let me take here radical number. Okay. Radical or radicate? Radicate. Okay. Radicate. Okay. Now answer. Unit place of answer. Suppose your radicand is ending with 1 or
1
only
only.
ending with 1. Only ending with 1.
1. Unit place 1
So
or 9.
unit place may be 1
Or
or
9.
it complement 9 with respect to 10. So 2
4.
possible. So of
4
course it
means
is ending with 4, then you can take 2
2
and
or
ending
8.
number here will be
8.
another, that is complement with respect to 10. Okay, if you take 9 here, it is
It will be
ending with 3
3 or
or
7.
7.
6
Okay, in
means
the same
6.
way,
4
yeah,
or 6.
if you say 6,
4
then
or
ending
6.
with 4 or complement is 6.
5
So
means
5
5.
you are taking, only 5 we are taking. If you
Okay.
take, if you is ending with any even zeros, so
0.
1 0 will come in. So radicand is ending with a 2 0. Then we will get 1. Okay, are you getting my point?
Okay.
If we say 4 0, if number of even number of zeros we require, the radicand. So this is the table we have to remember so that we can easily identify unit place digit of the answer by seeing the unit place digit of the radicand. Here,
Yes.
Okay.
please note down. ending with unit place of the radical. Let me write like that. Okay, unit place of radical. That is a good sentence. Okay, right. Now see, for this we need at least 1 to 25 space. Okay, we have to by head or we have to learn 1 to 25 square. Then you can able to solve the problems up to 249 squares up. So what you understand? How many squares you know? That many long square root of the lengthy square roots. Long means lengthy of the perfect square number you can easily find out by using below column without any division. Suppose if you know 10 tables up to 10 squares you know, then you can take the value up to 109 whole square. But because you don't know the 11 square value. Okay. Suppose if you know 41 square up to 41 square you know. So the maximum limit you can take up to here 419 whole square only. If you take 4203 whole square value in the place of a radicand, you're not able to solve it. Why? Because you don't know the 42 table here. So the maximum limit this one only. So the total game is based upon a squares only. How many squares you know, it depends upon that. That much quickly you can say the answer. I clear my point?
Yes.
Suppose if you know 99 square, up to 99 square, so that you can take 999 whole square value in the randicate. This is the limit only. 998001. This is the limit. You cannot cross the limit. If you cross the limit, you're not able to solve that problem. Why? Because you don't know more than 99 tables. What is my point?
Yeah.
Right. So remember this one. This is the concept for finding the square root of a perfect square roots. Okay. So perfect square values. Perfect square value. एक बात पूछूं आपको मनीषा. Right. So we need let me talk about here radicand value. In general, suppose look at now 3, 2, 3, 4, 5, 6, 7, 9 is there. What we are doing in general in division procedure, we are marking two digits here. Okay. So total here 4 pairs we are getting of a two digits. So it says that our answer containing 4 digits. Are you getting my point?
Yes.
But in our Vilokan method, what we are doing here 2, 3, 5, 9 we have. Am I right? 5, 7, 9. So first 2 digits we are marking to find the unit place. This place we can find by observation of the unit place digit. But here we are using here squares concept. So the remaining all these numbers we are considering as a second group. That means these 3 places we are taking as a single digit. That means here we get a 3-digit answer for this question. Why? Because I am taking these 3 digits as a single here. So here I want to take no 2 groups form. That is the reason I am taking 2 groups. But the leftmost group maybe contain a single digit, double digit, 3 digit, 4 digit, 5 digit, 6 digit, up to so on. It depends upon in the left side part how many pairs you are consider. It depends upon that. Clear my point?
Okay.
Okay.
You Manisha?
Yes.
This point you have to remember. In general, we are taking two pairs. How many two pairs you are taking? that many digits we are getting that. But in our VLOOKUP method, we are doing different. Why? Because we know some squares value. So the left part we are comparing with squares. We have the different methods. We will discuss one by one in the VLOOKUP. Okay, right. Now I will tell you very important point here. We can discuss while solving the problem or now also. There is no problem. Okay, actually we have the two possibilities in a solution. Am I right?
Yeah.
In these two
One or
possibilities,
nine.
we have to decide any one answer for the question. Any one.
Mhm.
So how we can decide? Let us let me discuss the problem only so that it is easy for us. Suppose look at now. Square root of, let me take here 2401. Okay, right. This is the first pair and this is the second. From the first pair, okay, from pair, first pair. What is the first pair here? 0.
1
So it is ending with 1.
to 9.
One.
So
One or
our answer, 2 digits answer. What is our answer? We have the two pairs now. So 2 digit answer. The unit place digit 1 or it complement 9.
Fine.
So now we can decide that it is a 2 digit answer, but because I have 2 pairs in the radicand, so it is ending with 1. So I can say that my answer also ending with 1 or a 9. Are you getting my point? Is it clear?
Yes. Yes.
Now come to the left part. If you see in the left part, if you can see 2 square, 3 square, 4
Between
square,
4 square and 5
square,
square.
6 square, 7 square, 9 square, and 10 square. So we can take here these values. After that, let me explain that. 0, 1, 0, 4, 0, 9, 16, 25, 36, 49. How much we can take?
Square mixed.
81.
81 and here. Now see, the number system is very important. The number system. I will use this number system back. Now see, this tens place is occupied by some digit. Is it clear my point?
Yes.
We don't know what is that. If you see the 24, it is nearest to which square number?
Yeah. 5. Yeah.
Fine.
Suppose if you take 5 here, why? Because the 24 is very nearest to 5. So if you take the 5, this 5, I'm talking about this 5, in the tens place, then what happens if you take the round figure? You don't find the value. If you take this is also 50 and this is also 50, just you take round figure, don't need to take 60. Then if you find the square of this number, then it is 2500. Yes or no? Just approximate.
Yes. 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 Yes.
My question is 2401.
So it cannot be 5.
But just I'm finding the answer of that question. If I'm taking the approximate value, that is 50, the 50 square is 2500. It is more than the radicand. It is possible.
No.
Then what we understand?
4.
24 is nearest to 25, but it is more than the 25. If you take the more than the 25, then the resultant also give the value more than the radicand.
Mm.
The square of the resultant value is more than the radicand. So what we can do now, we are choosing that the value which is nearest to the left part and the smallest to the left part. In that way, we have to select. So instead of 5, what we can select now?
4.
4.
4 we can select. So 4 we can select. Now our task is
600.
now you understood
1600.
which value we are going to select. The maximum
1600.
value we not select. We are selecting the minimum value. Okay, right. I hope you understood.
1600.
Right. So yeah, this is 1600. So almost it is more than the 1600 is less than the 2401. That is why we are fixed. There is no change. But my intention is that why we not take the value which is more than the left part. I have left part is 24. it is nearest to 25, but 25 is more than 24. So if you take the value 5 in the tens place, that the resultant value is for 51 or 59. If you take 5, and if you find the squares of the 51 and 59, that resultant value is very high than the radicand value. So then our answer becomes wrong. So that is the reason what I am saying. You have to take the minimum value, and that is the nearest to the left side value, that is 20. Right, that is completed. So now I have 41 and 49. From either these two options, we can select only one option. You know how we can decide that? Let me tell you that. Suppose 41 I have here, 49 I have here. Okay. So if we have the 42 and the 43 and the 44 and 45, the 46, the 47, the 48, the 49. Okay. Yeah, 49 is already written there. Right. Now see, sir, very important point and very interesting point from my side. Let me write the answers for all these numbers. Okay. Let me write the answer. Initially, the observation going like this. If I tell you the procedure, I can tell you it is it is not a problem for me. But you have to understand the procedure. Now it is 1681. Square of this number. I am writing squares here. Okay. So 42 into 42. 1764. Okay. And 43 into 43. 1849. Okay. 44 into 44. 1936. Next 45 into 45. 2025. Okay. Next 46 into 46. 2116. Okay. 47 into 47. 2209. And 48 into 48. 2304. And 49 into 49. 2401. Now see. Now अब देखिए important one. I can choose either 41 or 49. Okay, I don't know which value comes. But if you take any in between value of the 41, 42 to 48, if you take any in between value of the 41 and 49, okay, then we can easily decide that which is the correct answer. Suppose if you are picking 42, its square is 1464. But if you can say radicand here, 1764. If you see the radicand is 2401. So after 1764, we can see here 2401. Are you getting my point?
Yeah.
So we can select here 49. Suppose if you are selected 47, let us think you selected 47 in between value. 41 and 49 in between value, you selected 47. Its square is, it will be 2201. But oh sorry, 09. 2209. So if you see, if you compare the square of the 47, that is 2209, compare with radicand, it is again more than. So after 47 only we have the answer, either 48 or 49. We have the 49, so I am going with 14. Are getting my point?
Yes.
Suppose if you are selecting 47, the radicand is less than the 2209. Then we have the multiple choices, either 46, 45, 44, 43, 42 or 41. But we have the 41 here in the option, so I will select the 40. Now you understood how we can selected one answer from out of two.
Okay, sir.
But tell me one thing, it is easy every time to find in between value square of the 41, 49, every time it is possible.
No.
Sometimes we are getting the difficult number. Suppose 121 and 129 I got. Then you have to select any one in between or any one.
No,
then
sir.
it is difficult to find the square of that number, the increasing number of digits in the answer. So what we are doing, I told you, you can take any in-between value of 41 and 49. But the easiest one is 45. Why? Because we can find easily square of the 45.
Hmm.
Yes. Suppose 45 square we want to find. We are already discussed. This number is ending with 5. So the tens place digit is multiplied by its next number, success here. So 4 into 5, 20, 25. You can find very quickly answer. Suppose 95 whole square we have. 10 place is
9.
multiplied by success here number. So 90 into 25. So we can easily find the square of a number which is ending with 5. So instead of taking 42, 43, 44, 46, 48, in between number of 41 and 49, we are selecting the 45. It is very easy to find the square of that number. So let me take here in between number 45 square, that is 20, 25. So 20, 25. Okay, and we are comparing with 2401. So it is greater than, am I right? It is greater than. So it is greater than the 45. It means answer should be
9.
greater than the 45 only. That is 49 is our answer. So you got it, my point, every point here.
Okay, sir.
Yes.
How
Yes,
we are
yes.
doing the Vilokanam.
Yes,
This
yes,
is
yes.
the thing we have to do in a research.
Okay.
After that, observing all the points, we have to get the one conclusion, and we can say the class to everyone.
Okay. Yes.
So nowadays trainers, they are doing that one only. They are simply, they take 41, 49, in between 45, they will find out. They are saying this is the procedure. But first we have how to know why we are finding that. Why we are taking only 45. Why we cannot take other numbers. Everything we have to know. Okay.
Okay.
Yes.
So your radicand is more than the 45 square, answer will be more. Your radicand is less than the 45 square, then answer will be small. Simply two conditions. Right. Let me take here one more large problem. Why? Because you know that up to 30 square, I hope. Yes?
Okay, sir.
In a movie logistics.
Yes, yes, yes.
Right. 8, 2, 3, 6, 9 we have. So first two pairs, I will get first digit in a two possibilities.
We are.
So next three digit I am considering as a single digit. So this pair. Maybe that red color place maybe contain a single digit or double digit or triple digit. We don't know. After finding the values, we will know that how many digits we are getting. Of course, we can by the Vilokanam also we can see how many digits we are obtaining. But no need. Right. So this is number ending with 9. So 3 square is only 9.
3
You can
or
take
6.
3
3
or
or 7.
complement 7. Simple. Right. So 823. So 823 is very closest to 900 actually. But it is more than to the 30 square. Am I right? It is more than the 30 square. So let me take here, check the 29 into 29 is 841. But our 823 is again less than these two numbers, 29 square and 30 square. So we have to take now 28 square only. Okay, got it my point?
Yes.
Because if whatever value you are selecting, they are more value. So answer will be also more, you will get compare with original answer of the given radical. So I can take here 28, here also 28. So the in-between number I want to select this one. So we know that the answer is ending with 25 always, but because it's ending with 5. The rest of the number 28 is multiplied by ekadikena purvena.
9.
Okay. So how much we are getting? 812. Okay, 812. So 812. Now see this value. and we are now going to
Because
compare this value with the left part or total part. So total part is greater than. So answer also it is a greater than. Okay, clear my point?
yes, sir.
Yes.
Suppose let me take here based on same question. Let me take here the answer. Suppose 78,961. If you see that it is ending with 1, so I am taking 1 and here 9. And this is the value nearest to 28 square. Okay. So I am taking here 28, here also 28. In between number 285 square I am finding. Answer of this one is 81225. And the C, take the radicand 78961. So in this case, it is less than. Am I right? It
Yeah.
is less than.
Correct.
So it is greater than. It is greater. Here it is less. So the answer say it is less than the 285 square. That means it is 280.
One.
Are getting my
Yes,
procedure and
yes.
everything?
Yes.
Yeah. So
Yes.
how many squares you know? That much easy you can find the values. Otherwise, it is very difficult. Okay, clear?
Yes.
Yeah, right. This is the one way we can do by observing unit place. Another way also we have, this is like this. This method works effectively, but whatever methods I'm going to take, they works somewhere partially. Okay, right. Suppose what is the previous question? Square root of 789. So square root of 789 61. How many? Yeah, 61. So then we are getting 281 or 289. So last pair, if you see the last pair, okay. Here we are taking 285
Five.
holes. Then what we are doing, we are taking ekadikena of this number. So ekadikena, how much it will be? 81. Okay. Now observe very carefully what I am doing here. So this is the number. The left side part is multiplied by ekadikena, then only we are getting this one. Am I right?
Yes.
So this is 812. If you see this number, last three numbers,
Yeah.
it is less
Less.
than only.
Yeah.
Yes.
So we can choose less than answer.
Okay.
281.
Correct.
Okay, you got it, my point. Suppose uh, 2401 we are selected, the first question. So 41 we are selected, 49 we select. So 10th place we are written 4.
45.
So this 4 is multiplied by ekadikena purvena. That is we are getting 20. And last two digit we are comparing with this 20. So it is greater than. So answer will be 40.
Yes.
Is it clear my point?
Yes.
So what I am doing here, instead of finding all these number 285, just I am taking
Only
this part and multiplying and comparing with only last three digits. Why? Because these two digits I am not taking here. You can see.
okay.
Why? Because if you take 25 also, then I will compare with total digit. Here not I am taking 25. So these two digit will be, I am not going to consider for the checking here. This point is clear or not?
Yes. Clear.
Only we are checking left part.
This is the method came from this method or
Yes. Yes. Yes.
extra observation this.
Yes, sir.
But what happened here? I told you sometimes it will be works not effectively. Okay. For suppose you can see 12 into 96. So what we can understood here, the left part we are comparing here. It is more than this product, then we are selecting more answer. It is less than this product, then we are selecting less answer. Is it clear?
Yes.
Now come to this question. I hope you understood that concept. So this is ending with 4 or 6. The 12 is nearest to 9.
3.
Now see. So the tens place digit you are taking 3. So 3 is multiplied by next number 4. Then you are getting 12. Now this 12 is we are comparing with left part. Then what
Equal.
happened? We
Equal.
don't know whether it is now a greater than or equal.
Equal.
Or less than or equal. We don't know. Actually equal in this case. But I told you that suppose this product you are comparing in the left part. So the product is less than or greater than we are checking. Am I right?
Yeah.
Left part is
Equal.
greater than the product, then we are selecting bigger answer.
Yeah.
The left part is less than the product, then we are selecting less answer.
Yeah.
But in this case, they are equal.
So 25 next year to take it.
So when you are taking like that, somewhere we cannot identify that value. In the many
Yeah.
cases, 99%, it is also give the correct answer. In the some way, we don't know, like this kind of number. In that cases, we will get the equal digits. So when you are seeing that you are getting the equal digit, then simply go back to the 35 square. That is 1225. Simply 1225. Now 1225 and 1296. So it is greater than. Answer is greater than. So simply select 36. Clear my point?
Yeah.
Yeah. This is the one way. Sorry, second way. I hope this is clear or not? Let me
Clear,
do one more
clear.
problem.
Method 3.
No.
This
These are the
method 2.
corollary parts.
Yeah, corollary. Yeah.
Yeah.
Additional.
Additional of the original of Vilokanam method.
Additional observation.
Yeah. Now see. 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square. See, all these three concepts based upon the what?
Below.
Unit place only.
Yeah.
But from all this method, you have to practice one method and you have to teach to the children. Okay. As a trainer, I am giving you all the concepts to you to build your 84
Skill.
ఏందో అన్ని మర్చిపోతున్నాను చికాకైతుంది 84 ఏంట్రా 64 కదరా
64.
అవలే రైట్ ఓకే రైట్ నౌ see tell me one any square suppose 2601 is there. Okay, so this is ending with 1, so we are taking 1 or 9. Let me take the different problem. Okay, 1 or 9, 1 or 9. I'm bored. Three this one, 7 right. 2809. So this is ending with 3, 9.
Or
So you
7.
can take 3
3
or
or 7.
Now we can take here 28 is nearest to 5 square. But because it is less than the 28. If you take 6, it is more than the 28. So we cannot take the more values. Right.
55.
Right. Now this is 28 we have, am I right?
Yeah.
So this 28 actually in between these two numbers, am I right?
Yeah.
है ना 25 36 बीच में रहते हैं 28. It is in between the 25 and 36. If you see the difference of these two numbers,
3.
how much?
3.
3. And difference of these two numbers?
7.
8.
8.
So which one is nearest?
25.
3 is nearest.
That means smaller value.
Yes.
In the 36, in the 25, the smaller value
So
we are
53.
select. So the 28 is needed to smaller value. So answer is the smaller.
53.
Are you getting my point?
Yes.
But this works when you are taking the radicand as a bigger digit. You don't take the smaller digit. Okay.
Yeah.
But because sometimes it may be tied. The difference of the difference, you can see difference I got here 3 and 8. Sometimes difference will be both will get same. In that case, this work never works. This method.
Yeah.
So whenever we have the largest values, we can find very easily. Suppose 114 is there, not 114. 225. Sir, ekkado work kaadalendi. So are you getting my point?
No.
Sometimes
Yes.
maybe these two difference may be same. Okay. In that case, we cannot tell the correct answer. So that again we have to go with a
Middle.
general method, Vilokanam method. Okay. So let me
Yeah.
take it one more problem. So 7396. So what we can observe here from the unit place, we can write 4 and 6. Okay. The 73 we can take 8 square. That is 64. Right. Now this the second part is in between 64 and 81. If you see the difference between here 64 and 73, that is 9.
9.
And if you see the difference between 81 and 73,
8.
that is 8. So
So
here this is the
86.
small, this is the smaller,
So 86.
this is the bigger value. So it is nearest to bigger value, it means 86 our final answer. Yes, clear my point?
Yeah. Yes.
This is also observation.
Yes.
This is the one method. So whatever method we have learned today, those method based upon the unit place concept.
Yes.
We can take 2 digits, that is unit place and tens place. This is also we can take and we can identify the values. Okay. Right. But if you know the squares of the base numbers and sub-base numbers and ending with 5 numbers, you can find the squares of the larger numbers effectively. That is also a corollary method. But on that method, we are not going to take any unit place digit. We are taking the base concept there. 1 or 2 years back, I developed that method. That works very effectively whenever the answer having 3 digits. Actually, 3 digits it is very difficult because we don't know 3-digit squares actually. Am I right?
Yeah.
So that method works very effectively. We will discuss day after tomorrow. You have to practice all these 3 cases. You have to master it. Then we will discuss that one also.
Okay.
So
Working
the
base
sum
method.
see whatever. In this case, this method never works when we are getting the difference is same. Am I right?
Yes.
And this method is never works when the product and the left part is both are same.
Yes.
Right.
In my method also little bit some disturbance is there. I forgot it because 2 years back I found out that. Let me go through it. Okay. Actually, I did a video on it. Just I want to go through that video. It is already available in the YouTube. Okay. So that is the reason I am making the videos. Because I have a memory loss. Okay, clear?
Okay. Clear. Yes.
Thank you. Bye.
Thank you. Bye.